As our third example, we're going to evaluate some powers that have fractional exponents where the numerator is a number other than 1. So if we look at example A, we want to know what is 0.01 to the exponent 3 over 2. So we use our rule. The base is 0.01, so that means our radicand is 0.01. The denominator is a 2, so that means our index is 2, and you can write the 2 in there, but it's not necessary. And our exponent is going to be the numerator, which is a 3. So we are going to evaluate the radicand part first. So the square root of 0.01 is 0.1. And we want to raise that to the power of 3, which means I want to know what is 0.1 times 0.1 times 0.1, and that gives me an answer of 0.001. If we look at B, we want to know what is negative 27 to the exponent 4 over 3. So the strategy again is to write it in radical form. So our base is negative 27, that becomes our radicand. Our denominator of 3 becomes our index, and our exponent is the same as the numerator, which is a 4. So we're going to do the radical part first. We want to know what is the cubed root of negative 27. So what number multiplied by itself 3 times will give me negative 27? That is a negative 3. And now we're going to raise that to the power of 4. And remember, that's not negative 3 times 4. That's negative 3 times negative 3 times negative 3 times negative 3, which is actually 81. If we look at example in C, 0.75 to the exponent 1.2, you'll notice that our exponent is currently not a fraction. So what we have to do is change it to a fraction. So if we recall from grade 8, 1.2 right now is written over 1. So if we want to get rid of the decimal, I have to move it one place to the right, which means I also have to move it one place to the right in my denominator. So now I actually have a fraction of 12 over 10. And if you'll notice, 12 over 10 can be reduced because they're both even. So I can divide 2 out of both of those, and that would give me a fraction of 6 over 5. So the exponent 1.2 in fractional form is actually 6 over 5. So I can rewrite my question as 0.75 to the exponent 6 over 5. And now to solve it, I can actually write it in radical form. So my base is 0.75, so that becomes my radicand. My denominator is 5, that's my index, and my exponent is the same as my numerator, which is a 6. Now this one's probably not as easy to do in your head because it doesn't work out to a friendly number, but if I use my calculator, the fifth root of 0.75 rounded to 4 decimal places is 0.9441. And if I raise that one to the power of 6, so I take my answer and I multiply it by itself 6 times, I'll get an answer of 0.7081.